Good morning, students. So, we will discuss in today's class about final control element. So far, we have learned about different control schemes, that is feedback control, feed forward control, the control variables, different control actions depending on modes of control actions, uh, different controllers, and now the if we consider the control loop, that is there must be a process measuring devices by which the process variable is to be measured. Then the measured process variable is to be compared with the set value, and the controller will take the corrective action. Then that output, the controller output, will send to the final control element. We have learned about different controllers, and next is final control element. So final control elements are again of different types depending on type of energy input. It may be pneumatic, may be electrical or electronic type. So in first level we will discuss about pneumatic operated final control element. Final control element have two distinct parts. One is actuator, another is control valve. So for pneumatic controller, the two basic different type of actuators are there, or the final control element is either air to open type or air to close type, or in some book it is termed as air failure to close type and air failure to open type. This is air to open type or air failure to close type, and this is air to close type or air failure to open type. This is defined in different books as in this way. So there are two distinct type of final control element in pneumatic systems, and the different types of actuators. So two distinct part of final control element is actuator. Actuator is the sensing part, that is the controller output should be sensed by the actuator, and accordingly the valve will be moved in such a way that the energy adjustment to the process can be done. So depending on type of operating energy, the actuator may be of different types, that is pneumatic, hydraulic, electric, or combinations of these. And so final control element may be classified as pneumatic diaphragm actuator control valve. Butterfly control valve is a special type control valve for special action. Hydraulic control valve, that is using oil or fluid type operations, that is hydraulic control, hydraulic actions. Electric motor actuated control valve, stepper motor actuated control valve, both are electric operated, but one is continuous rotating type motor and another is stepper motor, where step type of action is required. And you are familiar with this pneumatic control valve system, that is the upper portion of this is called the diaphragm, this is the actuator, and this portion is called valve. So basically this portion is valve actually. This is called the plug. See, this is the plug, and this is called the seat. This portion where the plug should be fitted is called the this portion where the plug should be fitted is called seat. This is the seat area and this is plug. So normal flow path within the valve is through this and then out through this. This is the normal flow path of the fluid. Then when the this plug gets fitted to the seat area, then it restricts the fluid flow through this path. When it will happen? If the air pressure, this is the diaphragm, see, this is the diaphragm as labeled, and this is separated, this separating the upper portion with the lower one. The lower portion of the diaphragm is connected with the spring. This is spring type actuator where the restoring force is provided by the spring, and this signal is coming from the controller. This is pneumatic, so this is the air pressure operated. So this air pressure is coming from the controller output. So the controller output is sent to the upper part of the diaphragm of the actuator. That will be compared with the spring force, that is the restoring force. And if the upper pressure is more than this spring force, then what will happen? The diaphragm will be pressurized downward. As a result, this is called the stem. The connecting portion of the diaphragm to the plug is the stem. So if the downward pressure is more, then the stem will move downward and the plug will gradually closes the seat area, so that the outflow of the fluid flow through this plug or through this valve will get restricted. So this is the valve operation. This is the spring type pneumatic valve where the restoring force is provided by the spring force, or sometimes there is a if there exists no spring, it may be there is a pressure source. The lower portion of this diaphragm may be connected with a pressure source, that is the compressor. There may be another device, that is the compressor. That is, there is a constant pressure supply at the lower, and the upper pressure will be compared with this compressed air signal. So the restoring force will be provided by the compressed air pressure. That is called springless actuator. This is the spring actuator. Now air to open type means, I discussed this earlier also during on-off controller, that air to open type or air to close type means, say for this control valve, when air reaches to the diaphragm, what happens? The downward pressure increases. As a result, the plug fits to the seat area and it restricts the fluid flow. So when air increases, then it gets closed. So this is air to close type valve. When air increases, that means the input signal increases, then it gets closed. So this is the air to close type. And air to open type means when due to increase of this air signal, the outflow increases. When that may happen? if this plug is positioned at the lower portion. See, instead of this plug at the upper portion, if the plug was at the lower portion, what will happen? During when the air pressure increases, then the stem moves downward direction. If the plug is at the lower portion of this seat area, then the the path will be more open. So this is air to open type. So the structure of the valve will be completely different for air to open type and air to close type, or it may be stated as air failure to close type or air failure to open type. That means when air fails to reach due to instrumental failure, if air fails to reach at the upper portion of the diaphragm, that is the type of air failure to closed type and air failure to open type. So pneumatic actuator is a device that converts controller output into the motion of the valve stem. The actuator may operate differently by the output signal of a controller, or may employ a separate source of compressed air, that is which I mentioned that for spring type actuator, the restoring force is coming from the spring force, or for springless actuator, a compressed air source may be used for control valve operation. The pneumatic actuator may be of different types depending on principle of operation, maybe spring actuator or springless actuator. Again, spring actuator without positioner and with positioner. What is positioner? I am coming to discuss about positioner, but spring actuator and springless actuator is clear now. Piston actuator is a type of operation using a piston within the actuating system, and all these are pneumatic actuator. Electric actuator may be continuous motor type, that is electric motor type, or stepper motor type. Now, functioning for pneumatic controller, the diaphragm is generally made of neoprene rubber or metallic wire, reinforced neoprene rubber supported by backing plate at the center. The air pressure acting on the diaphragm is the controller output, that is M minus M0 into A. A is the diaphragm cross-sectional area, where M0 is the control action signal at zero stroke condition, that means when there is no action, and M is the control action signal. Just to remind, I want to mention that M is used to signify the change in manipulated variable, because the control action is purely dependent on the change of manipulated variable. That's why it is written as M, and this M0 stands for zero stroke condition, that is when no change is there, or constant parameter. Now let this force produces a displacement x of the control valve stem movement due to the this force. Then the if there is a spring force, then due to this restoring spring, the spring force action is this F is equals to K into X, where K is the spring constant. So that is equals to M minus M0 into A for spring actuator. Now the standard range of the actuator input signal, see, all these points are very important in terms of pneumatic control valve or pneumatic actuator. The standard range of actuator input signal or controlled output signal is 0.2 to 1 kg per centimeter square, and the stroke length of the valve stem is generally lies between 1/4 inch to 3 inch or 6 to 75 millimeter. But the standard allowable stroke length, that is the total range, is limited to 1 inch or 25 millimeter. The performance of the spring actuator will be satisfactory if the following conditions are maintained. What are the conditions? The force of on stem should not be high such that the material of the stem may operate within elastic limit. The natural frequency or that means the force should be such that the material elastic limit should not cross. If it exceeds the elasticity, that means if it reaches to the plastic region, then it cannot be restored again. So the force of stem should be within such a value that material should operate within the elastic limit. That is one condition. Because the diaphragm is made of neoprene rubber, so the force, and the stem is a metallic stem, but the force should be withstand within the elastic range. Next is the natural frequency of vibration should not be greater than 25 Hz, where the natural frequency is determined by F natural is 2 pi root K by M. K is the spring force and M is the mass of the moving system applied to the spring. That means it should be operate within the periodic natural frequency of the vibration should be periodic. The static frictional force must be limited to a low value such that the effective hysteresis loss is very small. All these purposes are to be taken care for design consideration. So valve designing is a critical issue for the control whole control systems. So if MR is the range of the input pneumatic signal, then hysteresis loss will be less than 1% of the full travel of the static, that is the range of the static range of the valve path. When the static frictional force satisfies the relation, this is the frictional force FF, should be less than MRA by 100. This is the condition to operate the valve within the full stroke, or rather one, so that hysteresis loss can be maintained within 1% of the full travel of the static frictional force. This is the very serious limitation of the actuator, since it produces a limiting value of the frictional force which may not be achieved in practical case. Say for control signal 3 to 15 psi, that is the standard range, and the actuator diaphragm of the effective area, this is the diaphragm 100 square inch, and the control signal that is coming from the controller output is 3 to 15 psi as standard. Maximum value of the frictional force that should be maintained using this MRA by 100, this is the range is 15 to 3, so MR is 15 minus 3, area hoche 100, area is 100 square inch and divided by 100, so this is 12 pound. So in order to maintain the control signal for the effective area this much, the frictional force is 12 pound. The total thrust force due to the process fluid acting in one direction should be less than m0a, where m0 is the as mentioned earlier, that this is the controller output or input signal at zero stroke condition, and a is the diaphragm area. And also this force should be constant throughout the whole range of the controller. Otherwise, input signal will not be linearly related with the stem movement. That is another important aspect, that the stem movement and the input signal should be linearly related. Otherwise, the operation, if it is in the non-linear region, then the operation will not satisfy the controller movement, control valve movement in the linear region. The characteristics of the spring and diaphragm should be within the elastic limit, and the effective area of the diaphragm and the spring constant should remain constant throughout the full stroke of the valve stem. Otherwise, linear relation between input signal and valve stroke, that is mentioned in a previous point also, that characteristics of the spring and diaphragm should be maintained within the objective is we should run within the linear range of input signal to the valve stroke. And hysteresis effect of the spring and actuator should be less than 1 to 2% of the full stroke. That means hysteresis loss should be maintained within the 1 to 2% of the full stroke. Next is valve positioner. We have mentioned that spring actuator with valve positioner or without valve positioner. Valve positioner is an additional feedback element. That is, when static friction, hysteresis, unbalanced thrust force acting on the motion of stem of the control valve are large, or the response of the actuator diaphragm is too slow, especially in case of single-seated valve. This is another term we will discuss in valve portion, that single-seated and double-seated valve. So that the response of actuator diaphragm is too slow for the valve. At this stage, you should consider it as a valve, maybe single-seated or double-seated. The simple spring actuator cannot position the plug at the desired position. That is, a slip occurs between the plug and the seat area. It cannot fit properly at the seat area. So, in order to fit the plug at the desired position with an accuracy as desired by the controller, in this case, an additional feedback element is used called valve positioner along with the spring actuator, just to position the plug at the seat area tightly or properly. This is the spring actuator with positioner without booster relay. Booster relay is nothing but an amplifier. In order to amplify the output signal, a booster relay is used. A valve positioner is the device which is used to position the valve stem at the desired position with high accuracy. It is generally two types: valve positioner without booster relay and with booster relay. Booster relay is just to amplify the output signal coming from the controller. So this is without booster relay. So say this is the input signal. Again, this is motion balance type. So this is input signal. If the signal increases, then this end will move upward direction. So the flapper, this behaves as a flapper towards the nozzle element. so it gets closer to the nozzle element, so nozzle feedback pressure will increase. That is the this combination is the controller. So the controller output goes to the final control element. This is the diaphragm or the actuator portion. Then the pressure will increase and the stem will move downward direction. And see, this is connected with the stem directly. So as this goes downward, then this portion will move downward direction. As a result, the stem will move towards the seat area, or if it is air failure to open type, that is rather you should understand that seat stem will move downward direction. So whatever be the type, accordingly it will take the action. And this is the with positioner. This is without positioner, where there is no feedback arrangement is there. This is with positioner, where the stem is connected with the flapper system as a along with the spring arrangement, so that when it goes downward from whatever be the type of flapper nozzle arrangement, if the nozzle feedback pressure increases, the pressure at the downward pressure on the diaphragm will increase, so the stem will move downward, and as a result this will move downward, so this end will move leftward to the left. So due to this spring force, the flapper will move away from the nozzle direction, and again the output pressure will decrease. So this will automatically adjust the seat stem movement, so that the plug can be fitted to the seat area properly. This is called positioner arrangement. This is just a feedback element. And booster relay is the just a pneumatic relay along with this flapper nozzle system. So this is the arrangement for spring actuator with positioner. This is the with positioner, and this is along with booster relay. So positioner is basically a feedback element. In the positioner of booster relay, the feedback pressure of the flapper nozzle system is for booster relay, the signal is amplified by the booster relay such that the desired volume of air may be supplied to the actuator for producing a certain movement of the valve stem. With the increase of input signal, the flapper moves towards the nozzle such that nozzle flapper pressure increases, and so the bellows element of the booster relay connected to the nozzle chamber moves to the pilot valve or stem to the towards the exhaust port. This increases the feedback pressure of the relay chamber, and so the pressure in the actuator increases, and the stem movement moves downward until it attains the desired position. So this is just a feedback element. This is the positioning system. Along with this is the flapper nozzle, that is controller. This is actuator, and the stem movement is with the booster relay, and this is the positioner. This is the positioner acts as a feedback element. Advantage is it helps in overcoming the stem friction through high open loop gain, because it gradually changes the movement towards upward and downward direction, so high open loop gain can be overcome. It accurately positions the control valve stem at the desired position, irrespective of the bench range or the unbalanced force of the valve stem. Hysteresis effect is reduced by the positioner and is linear between the valve stem and the control signal is improved by the action of the positioner, since the effect of static friction is counterbalanced by the amplified signal produced by the positioner. Positioner with booster relay can handle much frictional force, since the signal can be enhanced using booster relay. Variable thrust force acting on the stem cannot disturb the accurate position on the stem due to the action of the positioner, and speed of response of the control valve is increased by the action of booster relay in a positioner. So there are several advantages using valve positioner. This is the springless actuator. Again, it may be with positioner or without positioner. For springless actuator, instead of providing the restoring force by the spring force that was present there in spring actuator, the restoring pressure or the balance force is provided by a compressed source, that is the pressure regulator. And rest actions are exactly similar. This is for piston actuator. Actually, diagrams are enough to discuss about the action. For piston actuator, this is the piston arrangement connected to elements connected with a rod. This whole arrangement is a piston. That means when it moves upward, the whole element will move upward or downward. This is the inlet fluid flow, and this is the controller output. That means when signal comes, and if the pressure increases from the controller, what will happen? This is the input signal, that is the constant supply. Like flapper nozzle system, 3 to 15 psi. So if the pressure signal from the controller output increases, that means the downward pressure increases, then the arrangement will move downward. These are the paths. Those are closed by this piston. So just think about if the piston was at the upper position, say here, then what was the diagram like? This is the upper part, and at that case, the and say this is here. So this is here. When the path remains open, and this should be connected like this. So when the piston is say with this position, then the output paths are open, and this is the valve, rather actuator. Valve is at the lower portion. This is the actuator. Then what will happen? The input signal can flow through this, and when the pressure increased, then the plug, the piston will move downward, and as it goes downward, it will in turn closes the outflow path through these paths. So the upper pressure, it closes means the upper pressure signal get closed and so initially there was a signal. When the signal is allowed through this path, then there was a signal. So this will cause the thrust to the downward direction, and the stem will move. And if the pressure decreases, then it will move upward direction, and never both these paths will get closed. So either this pressure, when it goes upward, then the lower portion will be opened. So the lower pressure, lower chamber pressure will increase with respect to the above one. Then the upward thrust will be more. As a result, the stem will move upward direction. So this is the functioning of piston actuator. Only if we understand the diagram, then we can explain the functioning. This is pneumatic motor actuator. A similar type of the piston arrangement for the input signal path. Here is the controller output, and this is the constant input supply. So when the piston arrangement at the upward portion, that means when this path is open, the air signal will flow through this, and when this will get closed due to the downward force of the controller output, then the upper path will get closed, but the lower one remains open. Then what will happen? When this path is open, then the air signal, this is the arrangement of a pneumatic motor, means there is a motor system. Due to this air thrust, the motor will rotate, and there is a gear arrangement. This is called rack and pinion arrangement. This is the pinion, and there is a rack arrangement. This is the pinion, and this is the rack arrangement. So when the motor will rotate, the pneumatic motor will rotate, due to this air pressure, what will happen? This will move, this rack will move at the clockwise direction, and as a result, the rack will move downward direction, isn't it? Just think about this, that when the air pressure is coming from this side, then the pinion will move clockwise direction. As a result, the rack will move downward direction, so the stem will move in the downward direction. Again, there is an arrangement of positioner, then it will move to the other direction. So in turn, the upper path get closed and lower path get opened. So the pneumatic motor will run in the opposite direction. That means in the in the counter, not in this direction. Yes, in this direction. So as this path, so this will move to this direction, to the counterclockwise direction. As a result, the rack will move upward direction. So the stem again will move to the upward direction. That means not in a single chance, but a number of chances the valve will position at the desired position. That is the purpose of this positioner, and this is the functioning of pneumatic motor actuator. So there are different types of hydraulic actuator is exactly like this piston actuator. Only difference is this is oil operated, and this is for pneumatic operator, this is air pressure, air signal operating. So that's all about the actuating systems, and in next class we will discuss about the control valves. Thank you.